Up first is Chris Unwin. He is going to clone all the things. And so that's take it away, Chris. You go.
Fantastic. Thank you very much, Grant. And yes, hello there, everyone. Hopefully, maybe some of you recognize my voice. My name is Chris Unwin. Just a little bit more on me in just a second. But this session is going to be on clone all the things because you have to shout italics. Just a reminder, if you ever see italics, you've got to shout them. So we're going to talk about how database clones can enable faster delivery of value in your DevOps pipeline. And that all sounds like words, words that will hopefully, by the end of this session, make perfect sense and you'll know exactly what I mean. But I will be breaking it down, so don't worry. Hopefully everyone can see me. I don't know if I've got the little chat window. I do have the group chat window. There we go. So hopefully, if everyone can see my slides. Oh, fantastic. Yeah, we've got the group chat. Feel free to let me know if you can see me in the group chat window there. Big thumbs up from everyone. All I need a yes. No, not Baby Shark. Excellent. Looking forward to that. Okay, so let's move on. So yeah, hi everyone. My name is Chris Unwin. I am a solutions architect with Redgate Software. I'm also a blogger on Plant-Based SQL, Twitter under the handle @PlantBasedSQL, and also again, where some of you might be recognizing my voice from, I am of course one of the dynamic Chris's, the dynamic duo on DBAL. And in fact, we will also be doing a DBAL themed quiz. Well, not themed, we won't be asking you questions about DBAL. But if you want to join Redgate's pub quiz a little bit later on, there will be some exciting questions, and I will be joined by none other than the dynamic, the incomparable, the wonderful Kendra Little. So this is where I'm being massively eclipsed by the incredible brains present on Redgate streamed today. That being said, I always like to make new friends. So if some of you aren't following me on Twitter, go over to Twitter, the Twitter machine, and plug in Plant-Based SQL. Send me a tweet and let me know what you think of this session, what you think about my fence panel blowing away in the wind. I was disappointed. I really don't mind. Let me know where you are and where you're watching this. And it's always great to stay connected. You'll notice that Chris Kurzweil from DBL is not with me. We can all shame him because he decided to take this week off, forgetting it was Redgate stream. So shame, Chris, shame. Now, what's the goal for this session, though? Why am I here talking to you today about database cloning? Well, the goal today is to understand how database cloning can help ensure value in and speed up a database change management pipeline. That's what I mean by that DevOps process. Of course, that includes database source control, continuous integration, and continuous delivery. So we've got that, lovely database DevOpsy process there. We've got our pipeline in place. How do we ensure quality by leveraging something like database cloning? So this is generally the area where we talk about database cloning. Naturally, it's the most obvious place. People actually talk about database DevOps. So here is what Redgate would class as database DevOps or compliant database DevOps. However you prefer it, database change management. I'm not going to tell you what to think. That's later in the session. But effectively, today we're going to be looking at one key area. So just for simplicity, for completeness, database DevOps, what is it? Well, developer makes a change. Makes a change against the database. Unsurprising there. That change then needs to get into source control in some way. It then also needs to be obviously validated, checked, tested. The wonderful part of this process is that it's very rugged, very robust, that we're testing maybe automatically, maybe practicing test-driven development. Yeah, no, I'm not either, but shh, don't tell anyone. We then have the continuous integration build, the spitting out of an artifact, a nice little release package, as it were. And then, of course, we get to release management, and we start talking about promoting up to other environments, all the way up to production, of course. Now, naturally, after that, there is still part of the process, and we need to talk about how developers get environments. That is a prerequisite pretty much for this session. So most commonly, how do developers spin up non-production environments? What is the most common way? Well, let's talk about the code side. Let's talk about our C#. Let's talk about our Java, for instance. Take a moment. And realistically, getting a copy of the most recent kind of production code is really as simple as going, hey, git clone F5, sorted. That effectively is going to, being attacked by a fly, that effectively is going to give us the latest copy of the code to work on. And we can check out new branches, we can get everything up and running, and we don't have to worry about that. Now, databases are slightly different beasts, a slightly different kettle of fish, as we would say in the UK. To use a cruel and archaic metaphor, I could say a kettle of toefish. It's going to be big. It's going to be huge. So effectively, because of all that data, naturally we are restrained in how we can create non-production environments. And in fact, wait, back up. That is exactly how we create our environments. That's exactly how we create our non-prod environments. Production is 2 terabytes. Now, I'm not going to go out there with a blanket statement and say, your database, pointing is rude, your database is 2 terabytes in size. And actually, realistically, it could be anywhere. Some people will have hundreds of databases at 200 gig a pop. Some people might have 2 or 3 monolithic 20, 30, 40 terabyte databases. Now, I'm not saying that's wrong. I'm just saying that's where you are. Now, the problem is a lot of people like to back up and restore databases. Standard. It's been kind of the most obvious way to create database copies up until this point. It's almost like the GIF of Oprah. You get a database, you get a database, everybody gets a database. The problem with that, though, is kind of fourfold. And if you've ever been on a session with me before, first of all, my condolences. I'm sorry about that. The second thing, though, is that we're going to suffer from major, major problems. We're going to suffer from a space headache. As you can see right here, if a 2 terabyte database in production, well, then copying it multiple times into dev, into integration, into testing, into QA, well, that's going to cost you 12 terabytes of pre-production storage. And I should also point out, what developer has a 2 terabyte SSD available to just pop a copy of the database on it? Don't need no operating system. I've got just enough room for the database. Well, oops. So naturally, we need a way of solving that. The time actually involved in this as well is a huge, huge drain, not just on kind of database administrators or infrastructure engineers or people who are responsible for creating these copies, but also for developers. Remember, we're trying to be agile here. We're trying to be nice and quick and minimize context switching and waiting and all of these other pieces of waste that we accumulate. And again, if you haven't read the Phoenix project, highly recommended. Highly, highly recommended. Also, hello, Mr. Yates, if you're watching, who made me read the Phoenix project first, and excellent, well done. So these are the problems: the backing up and restoring, the space, the time, the actual waiting for things. And obviously there are additional ones as well, kind of secondary problems that this causes. Because we can't refresh them often enough due to space or time, people get forced into shared development environments. And if you've ever tried to work in a shared development environment using, say, Git and branching and merging, you've got a team of 10 developers, one database, multiple branches, everybody's putting their same work on the same database. Absolute nightmare. Absolute nightmare. So we need, again, the ability to speed that up. And beyond that, also refresh rates. Actually being able to refresh our environments often enough so that developers aren't working on outdated data. The number of times I've spoken to people who say, yeah, I think the database was refreshed not long after I joined. Oh, really? When did you join? About 4 years ago? Excuse me? it's almost unconceivable, because it's like working on a really early version of code and not having the latest changes, and then trying to piece together kind of everything. And then your testing's not going to be realistic either, because your data is so out of date. I won't even go on to the data privacy concerns that raises as well. Still being attacked by this fly. Finds me very interesting, clearly. So what is database cloning? What is SQL clone that we're going to be talking about today? Well, SQL clone is a Redgate solution. And effectively, it's a simple, straightforward approach to getting started with standardizing development practices. What I mean by that is we're able to give everyone a standard from which to work. A lot of people will look at the Redgate website and they'll go, okay, right, standardize, automate, monitor, protect. Those 4 areas make perfect sense. But the point is, clone doesn't help with one of those areas. It helps with most of those areas. So it's a nice standardized approach. Everybody gets the same thing. Everybody's working on the same grounding. Everyone's working on the same footing. It's an excellent way to save on space in non-production environments and the time that's required to create those 40 megabyte copies. So remember what I said, okay, everybody gets their own copy. We're not looking to say, just drop a copy in at full size, 2 terabytes. That would be, again, a bit of a nightmare. So fortunately, we use the volume shadow copy service, the VSS, in 64-bit Windows that allows us to just spin up copies as and when we like. Effectively, we take a single piece of the database, right? We take the database itself, either from a backup or from a SQL Server database. We virtualize it, we centralize it, we put it on a file share. And that copy then acts as the basis for our clones. And we can automate all of this with PowerShell. There's a module for data masking as well. So if you have heavily regulated data that you need to protect, well, naturally, of course, there's an option for dealing with that. But the point is, we can give everyone their own dedicated databases. Now, you'll notice that I did not say we can give everyone their own dedicated databases for dev or for test. I said for everything. And that is the point of this session, is basically it is a really cool way to create databases. So what can we do with SQL clone? Well, let's first see it in action. Let me try and get my screen shared here. Hopefully that should kick in. Come on 24, I believe in you. 3, 2, screen share. It will come up, I promise. There we go. Fabulous. Right. Okay, so hopefully we should be able to see now in the media center that's coming through. Tremendous. Let me just scroll up. There we go. Brilliant. So hopefully everyone can see my garishly red Redgate screen. Hopefully it's not kind of caught you all by surprise there. But effectively, I'm just going to walk you through what SQL clone is and does. And this is it in all of its glory. Let's take a moment to just appreciate the work, the design effort that's gone into this. Big shout out to all of the product designers at Redgate, because they're absolutely incredible, and a lot of the research that goes into making sure that every box is just in the right place, well, it's very beautiful. It's super. And fortunately, SQL clone is, whilst it's beautiful, it is also an incredibly functional tool. So what SQL clone is going to allow us to do is, like I mentioned, we can create images. So that image is that single centralized virtualized copy. Instead of going, you get a copy, you get a copy, you get a copy, and everyone getting a restore with, say, their own files in it. You know, when we restore it, it gets its own MDF and LDF. No. What we do is we create one copy and then create differencing disks on top. So here I can say, right, create a new image from a SQL Server database. And I'm going to pick my Win 2016 instance to create an image from. And then I'm going to pick, let's say, blogs.redgate dev grant. Let's see what Grant's been up to. And I can hit continue. It's got first-class integration. So if we're looking at things from more of a data protection-y point of view, if you're trying to be compliant with POPIA or GDPR or the California Consumer Privacy Act or the rather aptly named, the very easy to say NIST 853 Revision 5 in the United States, try saying that 3 times fast. Then, of course, we have that integration with cataloging. It allows us to pull in any information we may need. And there was a wonderful session on data catalog a little bit earlier today. If you missed it, do go back and feel free to watch it when the recordings are available. Of course, we can provide any scripts, any data masking files that we like. So in this case, we could provide a data masking set that will sanitize all the data. We can drop SQL scripts that allow us to remap users, logins, permissions, etc. at a database level when we're creating these non-production copies. And then all we do, pick a file share, pick an SMB file share. Let's pop the let's pop the image on there, and then it'll be a case of, hey, spin up a clone, spin up a clone, spin up a clone. And we can put them on any instance that we like, as long as those instances can actually look back on that to that file share where that image is hosted. Now, here's a key example for you, just so you get the look and feel. Let's say that I'm a developer at Doggos Are Cute Incorporated, of course, the perfect business idea. And I work with a copy of the Stack Overflow database. And you'll notice that I have an anonymized image of the Stack Overflow database hosted right here on a file share. The image itself is about 91.6 gigabytes in size. Oh, it's a bit big. Fortunately, though, you'll notice that each of the clones that we create from this, and I've created one onto my Win 2016 development instance, is about 40 megabytes in size. And we can create them in seconds. We can reset them. We can drop them. It's entirely up to you. These things are ephemeral. And if I jump over into SSMS and actually take a look at that particular database, well, where is it? Stack Overflow Anon. We saw it was 40 megabytes in size. SQL Server doesn't think that. SQL Server thinks, oh, okay, it's a full-sized copy. Fair enough. But we're taking up 40 meg of local disk space. And if we take a look at the users, let's select those top 1,000 rows and have a look at what we've got. And tremendous. The Visual Studio component cache is out of date. Nothing could go smoothly, of course. Practiced all morning. Things broke. I broke them. I fixed them. They broke again. We got everything working. And then, of course, I am undone by SQL Server Management Studio. Now, fortunately, if I'd have had any queries open, though, naturally, SQL Prompt would have come to my rescue. That's right, SQL Prompt would have remembered all of the queries I had open, even if we had a crash, even if we had an issue like that. So once SQL Server Management Studio gets itself sorted, we'll be able to take a look at that table. Now, fortunately, we can also do this not just through the user interface, but we can do so in a more automated fashion as well. And SQL Clone actually comes with a full PowerShell module. And of course, PowerShell loves SQL Server. I stole that from DBA Tools. Definitely, if you haven't heard of DBA Tools, go and check them out. They're wonderful. But it's true. It's true. Actually using PowerShell to automate all of this, well, it just makes sense. It's, one might say, ingeniously simple. I am shameless. So let's go ahead and run this. Again, I don't just have to be running it from the PowerShell ISE. It could be happening anywhere. But if we take a look at the activity then, you'll notice that it's creating that image for us. So that centralized copy is being spun up on the file share of our DM database here. At about 82%, it will apply any modifications. It's finished streaming the bytes across from the backup into the virtual hard disk. It's finalized, it's masking it. Once that's done, it's prepared, it's ready to go. It finalizes the image, and then it will just spin up all the copies that we need. And there we have it. 6 brand new development, testing, QA, UAT databases at the drop of a hat. There they are. In seconds. I'm putting them all on the same instance purely because I'm limited to how many instances I actually have. But they've all gone now onto my development instance. We can expand this, and you can see there we've got Dev Chris, Dev Kendra, Dev Tom, we've got QA, we've got testing, we've got UAT. So there we have it. That's effectively what clone can do. You can also set up specific permissions. This is one of my absolute favorite things in all of clone because it allows us to assign specific teams. And we can assign AD users and groups to teams and say, okay, these people have access to these images and these people have access to these images. And we can use one SQL clone installation and manage what every team can see and only what they need. That's it. They can only consume what they need. So that's really handy, both from a data protection point of view, but also from a context switching point of view as well, actually making sure, oh, I only have 3 options. I'll create my clone from this one. But as we're about to see, there are a few, shall we say, amazing fringe benefits that come with having something like SQL clone in place. And it's not just the ability to, say, spin up these databases automatically for dedicated dev and testing environments. No, no, no. Let's jump back so you can see me. There we go. No, no, no. Oh, goodness. I'm terribly sorry. There's my face again. But fortunately, there are other use cases. And I can already tell, I already know what you're all thinking. You've watched this and you've thought, wow, this clone stuff's pretty neat. Yes, yes, it is. But what we've done is we've looked at that backwards arrow along the bottom, okay? We've looked at, say, being able to pull back a copy from our production environment, whether that be a backup, whether it be a live SQL Server database, and we've looked at putting that into dev. Now, what we haven't looked at so much is actually once we get our databases into dev, say our dev test servers, for instance, where do we go from there? How does it enable us to now get those databases into source control? Well, fortunately, we can use a clone as a baseline. Yes, with one of the most recent updates to SQL Change Automation, that is the migrations plugin for Management Studio. We have a lot of people who don't like baselining as a script because, and this is quite a few people, because their databases have invalid objects, linked servers, circular dependencies, and there's so much that plagues our database. So realistically, if we could get around the whole, we don't need that baseline script. If we could just use a copy of the database as the baseline dynamically, well, that would solve all of our problems. The clones can be used for script validation, for shadow databases. We can use the clones as the build database, and because they're configured as the baseline, SQL Change Automation will store that capability and feed it through to the build so that when we actually build our databases, we clone and then build on top of it. So let's actually quickly see that in play then. So let's open up, once again, the screen share, screen 2. Going live now to screen 2 of Chris's setup. Come in, screen 2. And 3, 2, 1. Redgate. Okay, it still took time. My bad, but hopefully you should be able to see that. So there we go. And let's see an example then of using the clone as a baseline. So here I am in SQL Server Management Studio. It's a place very near and dear to our hearts. We're all very, very much happy to be working here. And you'll notice here that I have that copy of the DM database we were just talking about when we talked about clone, specifically automating clone. So let's say now that I decide I want to get that DM database under source control. So I'm going to go ahead and create a new project for it. And if we hit new project, we can then go ahead and say, okay, need a project name. Any thoughts? Yes, absolutely. So we're going to go ahead and call it the DM database. And we'll put it in, what project folder shall we go with? Let's go with working folders, TFS Git, not voice of the DBA. We want the DM database Git, and we can pop it in here. So we'll select this folder. There we go. We'll select our development source. So our development source is going to be an existing database. So we'll go with local and the DM database. There it is. And we'll hit OK. We hit next. Now, this is where you can set all of your fancy comparison options, your filters. This session is not about those, so I'm not going to set any. I'm a rebel. Don't at me. We're going to hit next. And we get to baseline. Now, beforehand, we could have used a migration script as the baseline, and it would have allowed us to target a database, generate the full script from that, and use that as our baseline. But again, that's where the problems come in. So we do still need to baseline. We need to know what we're working from. With migrations, we're building incrementally, but we've got to be building incrementally on something. So naturally, I'm going to pick this wonderful option here, the use SQL clone database as a baseline. This is brand new, by the way. Can we get a round of applause for the team that built this into SQL Change Automation? And we're going to pick an image. So all I've got to do now is put in my SQL clone server URL. So I'm going to go with the server, which is Win 2016, and we'll go with 14145. We're going to refresh our list of images, and there it is, almost like I prepared this session in advance. Don't be silly. I'm going to pick that top image there, the DM database. There it is. And I can now go ahead and create this project for the DM database. Now, I'm not going to stay around in SSMS. What we're going to do is jump on over into SQL Clone, because what we've seen now is you can see this DM database Redgate shadow has just been created. It's just created the shadow database for us, that kind of back-end copy that we can validate our scripts against. And that happened automatically without me doing anything in Clone. Back over in SSMS, we hit Done. And of course, now we've created our clone as baseline database for the DM database. And if we jump over to version control, what this will then do is allow us to commit, obviously, our initial project. So everything getting started with change automation. And we can go ahead and say, this is our initial commit. And you'll notice that we've got all of the schema model in there as well. So if you didn't know, Change Automation maintains this offline schema model for us to help keep track of those objects. So effectively, we can see that we've got the DM database project. That's what we created, and then all of those schema model objects. Now, I'm going to commit that initial commit and then push, and I'm pushing to a remote Git repo in Azure DevOps. Yes, I'm still using an old install of Azure DevOps. No, unfortunately, I haven't yet been able to change around any of the settings. And yes, I am pushing directly to that trunk branch. Don't tell my boss. That's fine. He's on holiday. But if we now jump across into Azure DevOps and have a look at the DM database, you'll notice that when we jump into repos, we should see there's the DM database. There's our DM database SQL project file. And we can see our post-deployment, pre-deployment, provisioning, schema model. And it's only once we start generating migrations from this that this will then go ahead and, build it with a clone, deploy the migration to it. Now, it will still pass the build because it's going to build the database from, I forgot to set a trigger. So let's just go ahead and run it. There we go. So if we run this build, you'll notice that the project settings just come in from the files themselves and say, hey, I'm using a clone as a baseline, so that when we build, that build is going to use the clone as a baseline as well. And for anyone familiar with the change automation build stage in Azure DevOps or in any of the other CI tools, there's nothing different. I point it at the SQL project file as normal. I tell it what I want the NuGet package to be called that's generated as normal, and I tell it where to do the build. Now, naturally, I'm using an instance of SQL Server. So here we've got the tools instance being used, and you'll notice it says it will publish the artifact as well when it's done. There is nothing different to this stage here. It is configured in exactly the same way. And if we jump over to the build, and actually have a look at the logs, you'll notice that it's just gotten up to the build SQL Change Automation project. And if we review in SQL Clone, you'll notice that it created the build database. Then, of course, it would have run any migrations against the build. And then it cleans up. It removes the clone, so you don't just have this clone hanging about. Now, that is pretty cool. because that's going to allow us to ensure that we avoid all these issues with invalid objects and all of the problems with our existing legacy databases, but we can still get them into source control. We can still build them. We can still put migration scripts on top of them. And effectively, that just means that we can easily test our changes. Even if I just go over into SSMS and I want to verify, I can just go and hit the verify button. There it is. And it just builds the clone again for us. So it's entirely up to us how we handle that. It is incredibly powerful. So we also need to talk about, once we've got this kind of process set up, and we'll just, hopefully you're seeing the slides here as well. I'm going to not stop sharing my screen, given that we've got so much time involved in waiting between transitions. So I'm just going to leave my screen up there instead of my face. Hopefully that leads to a slightly more pleasant Wednesday view for you. So moving on then, so we've had a look at bringing databases back from our production environment. We've had a look at spinning them up into dev and test environments, and that's useful in and of itself to help us move away from shared environments, to help us spin up environments at the drop of a hat with no issues whatsoever. And we've also had a look at how we can use them to baseline our SQL change automate. For instance, once we have our dedicated cloned database, and we've used it as the baseline or anything like that, we now have a dedicated environment to work on. So we link that environment to a, let's say, to a development branch in source control. Now, you do some development on that database, you type away, click, 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 click. Oh, I'm really happy with that function. Oh, that stored procedure is magical. But then someone says to you, oh no, Chris, major issue here, major issue. We need a bug fix. Could you please do that for us? I need you to do it immediately. So you spin up a bug fix branch. Oh, you've got all of this work that's been done on the branch in change automation and using your clone. And now what you need is something that you can spin up a branch for that looks just like the database did. So you can merge that in and then obviously have that go out first. So branching and merging becomes a huge pain in the, well, I'm sure you can guess. Now, what we can use clone for, though, is we can use it for branching. We can actually use it to check out a new branch. We can use a Git hook, a SQL clone Git hook. And I'm not just lying. This isn't a thing we cobbled together. It's in the documentation. It's right there. We can actually use the SQL clone PowerShell module for branch switching. So effectively, this allows us to spin up a new environment for each branch. It allows us to swap between those environments seamlessly and handles the actual renaming of the environments for us. So that means there is minimal waiting involved for developers, minimal time involved, minimal context switching. The database becomes agile, ephemeral, just like the code. Now, this is actually created. I'm just going to come back into a different working folder. Let's actually have a look at that Git hook. So I'm going to be using the voice of the DBA environment for this one. And if we come into our local repo and have a look at those hooks, you'll notice that we have two things here that are going to make this work. You've got the post checkout and the clone branch.ps1. So the post checkout is actually going to, let's edit that with Notepad++. So there it is. All it's doing is executing the clone branch PS1 with PowerShell there. And if we take a look at the clone branch 1 PS1 file, you'll notice that all we need to do is set this top bit. So we basically say, where's the clone server? What's the image name, the SQL server, machine name, instance name, etc., DB name, and then the rest of the script handles it all for us. Now, the point I'm trying to make is that this is all available for you right now on the Redgate documentation site. Is right here for you to just copy into your local environments, and you can get branching with clone right now, right this second. Go, I'll wait. No, I'm joking. Let's carry on. So just an example of this then, I said that I was going to use the voice of the DBA dev database. Now I'm just going to double check that I have in fact created myself a voice of the DBA dev database, which, oh, I have indeed. Whew. I panicked for a second there. So let's go ahead and close this one down and open up our Voice of the DBA SQL project file. Now, I did say this morning I managed to break, well, everything, and I did. And to me, that is just the sign of a good engineer, is that we break things and then we fix them without telling anyone. So I guess I've failed at that. But what we're going to do now is we're going to come over to the version control tab. And of course, we don't want to be working on our main trunk branch. So it's time that we check out a new branch. Let's create. If people didn't know, you can branch switch within Management Studio, within SQL Change Automation. It's very swish. And I'm going to go ahead and call this one, let's say, Feature 01. There we go. And we'll create that branch. So you'll notice that it's taking a little bit of time to do that. The reason that it's taking a little bit of time to do that is that you'll notice we have a rename here where it's taken our Voice of the DBA dev database and renamed it to _master Redgate because it's put the branch name and then our username and kept that separately. So any work I was doing on our trunk, that's kept separately. And then also we've got this Voice of the DBA dev that's been created specifically for feature 01. That's all it's there for. It just allows us to dynamically switch. Let's say that we wanted to switch back now. So we'll just wait for a second. And what will happen is some more renaming. We're able to switch back to the initial branch we had checked out. And there we have it once again. We're able to just click, 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 swap between these different environments. And honestly, it takes, well, as you saw, very, very little time indeed. So what have we been able to do? Well, we've been able to pull a copy back for dev and test. Thumbs up. We've been able to use a clone as a baseline for SQL Change Automation to avoid invalid object hell. Big, big thumbs up. We've been able to, what have we been able to do? We've been able to create, we've been able to check out a new branch and dynamically switch to it using SQL Change Automation. Fantastic, wonderful, even bigger thumbs up. But there's something that you can do with Clone that I really love. And I owe a lot of this to, particularly to Kendra Little as well. Effectively, Kendra was the one who pointed me at the fact that you can do this. Oh, I've had a question come through. I didn't even notice. Apologies there. So the question is, I'm not well versed in Git, but how do you distribute the Git hook for Clone? I thought Git hooks are not saved in the repo. No, I mean, each developer would then just basically take those files. You would just give them to the necessary developers on the team, and they would then customize those files. It's entirely up to them. It shouldn't interfere with the workflow for anyone else on the team. So yes, you're quite right. I'm not persisting that into the remote repo. So yes, you are absolutely well versed in Git. Please don't ever think that you're not. That was you're absolutely right. Hopefully that's answered it. I'm going to check it as answered. If it's not answered, please do feel free to stick around and I'll answer any additional kind of questions that we have at the end as well. Thumbs up. Right. So yes, Kendra pointed me at this thing that that you can do with Clone as well, which I think is really, really handy. And let's say that we've checked out our new branch. So we check back over to feature 01. We'll let Clone do the rename. There we go, successfully renamed. Jump back in, and we're on feature 01. So let's go ahead and make some changes to the Voice of the DBA dev database. So let's say that I've just joined the team and I've been asked, Chris, we want you to add a new column. Now, everybody who's ever seen me do a demonstration of Redgate's change automation will know that I'm a big fan of adding some social media information to the contacts table, of course. We want to collect some more social media information for our end users so that we can be more relevant and for advertising purposes, X, Y, Z. So, of course, we're up to date, we're relevant, we're hip, just like the young'uns of today. So I can go ahead and add a MySpace column. We'll start collecting MySpace handles for our end users. There we go. Now, we've added that column. I can now refresh the voice of the DBA project. The good thing is, remember, my voice of the DBA dev database has been renamed, so it's now on the proper branch that it's supposed to be, fortunately. We can click on that object and we can see how it's changed over time. We can see that MySpace column that's been added in there, and I can generate those migrations. Click. So let's get generating those good migrations. Grant should have warned you. Whilst he is more than happy to avoid singing, I do sing. So unmute. You can unmute now. So we can edit that migration script if we so wish. Again, if we're doing crazy things like adding, I say crazy, usual things like adding not null columns to tables or anything like that that might require some data messing, well, we could include that in the migration script. So we hit done. We've got our new migration script. I can jump over to version control and I can say something like, Grant told me to do this smiley face. And we can commit, and then I can push. And that's going to push, obviously, to feature 01 up in Azure DevOps. So I jump over into Azure DevOps, naturally. And if we take a look at our repos, you'll notice there's our code, so it's all good. Nothing reflects our latest change, except you'll notice here we've just updated feature 01. We should create a pull request. This is something I love about Azure DevOps, is that it's actually pointing it out for us. Now, for pull requests, naturally, we want to be able to, for anyone who doesn't, who's not familiar with pull requests, a pull request is effectively just getting a review of our code prior to it joining our main code repository, so our kind of trunk branch, as it were. And the good thing about using pull requests is that you can keep code quality high because you're getting that review in, you're making sure that people are casting an eye on that code. But as you'll notice, because I just changed slides surreptitiously, hoping that some of you might have noticed that, if you take a look at the slide, as you'll know, approving pull requests from our perspective is hard if we don't have a live environment to test against. So naturally, we get a couple of different options. As you'll see at the bottom, we either pull down the changes onto our database and then we have to try and undo them, or we're just reviewing a screen of code. We're just reviewing the changes. And unfortunately, that doesn't tell us anything about how the database interacts with, or how the changes interact with the rest of the database. But equally, we don't want to merge them back into the trunk immediately, because if there's anything in there that's going to make the database go fall over, well, we want to know that before we merge it in. Remember, that main branch should always be buildable and deployable. And if we break it, well, we've got all heck to pay. So I'm going to create a pull request for these changes. And what we can do is hit create on the pull request. And effectively, what's going to happen now is we're going to kick off a really cool workflow, certainly that you can do in Azure DevOps. And that's where I've set this up today. So you'll notice that we've got these branch policies in action. Now you can do so, you could set these branch policies up by coming to the branches in Azure DevOps. In this, I'm going to talk through the Azure DevOps specific workflow. Obviously there's different workflows, different policies in different systems, whether you use Bitbucket, GitLab, GitLab, GitHub. It's into GitLab. That's my new business idea, GitLab. And effectively in Azure DevOps, at least, you can hit branch policies. And this will allow us to add specific policies to the branch, in this case, require a minimum number of reviewers. If it's my code that they're reviewing, you're going to need at least 5 of them. You can check for linked work items, enforce merge strategies, and crucially, you can also use your database build to validate these changes. Now, what will happen is when a when a pull request is raised, what happens is we then build it using the Redgate tools like we just saw with Clone previously. And then you can build out a specific part of your pipeline. Anyone who's watching, specifically people like Rob or Alex, you'll know who you are. You may have just seen me using the classic view for builds. I should be using YAML. I know, I'm sorry. big smack of my hand there. For future episodes, for future streamed, I will 100% use YAML files. But in this instance, what we can do is we can also set up release pipelines. So if we take a look here, you'll notice we've got the database build. So that's producing that artifact, and it's pre-merging the pull request into the main branch and then triggering this build, which you'll notice then has a pull request trigger on it. So the pull request trigger is then actually just firing off and saying, right, we've got a new build artifact. We've got this new build artifact available. So it's now time to go ahead and deploy it. But of course, we don't know where to deploy it. There's no point just building it. We also need to test that we can release it. So that's where we then use the perform create and deploy to clone. We can then take all of what we've developed so far and deploy it immediately to a cloned database using, in this case, the clone plugin for Azure DevOps. It's available on the marketplace. You could just be using the PowerShell as well. But you'll notice that the release is happening now. Hopefully this will work as well, fingers crossed. So you'll notice it's now deploying to the clone. Fantastic. And if we jump back to our repos and take a look at the branches, there we go. So let's have a quick look at the pull request that we've raised. I should really talk about pull requests, given that this is about pull requests. So effectively, we can see that Grant told me to do this. Yes, Azure DevOps supports emojis. Big win for me. And over here on the right-hand side, you can see where our policies have been enforced. We have succeeded the build, and we've succeeded our new release pipeline. And if we come in and refresh now our view within SSMS, we should now be able to see that we have voice of the DBA _PR for pull request. Now, fortunately, we can also use Azure DevOps environment variables to actually put the number of the pull request on there if you're processing lots and lots of pull requests, I don't know, throughout the day. Again, I'm not you. I don't know how many pull requests you raise. It could be none. But effectively, this allows us to open up a real live database at the cost of a couple of seconds and 40 megabytes of storage. Can't get over that. Could be a terabyte database. Nobody knows. It's 40 megabytes. But if we look at our contacts table, there's that MySpace column. We can test it. We can run some automated tests. We can check it in a live environment to make sure that that is the kind of change we want to actually merge back into our trunk branch. So now I can jump back over into Azure DevOps, and naturally, because my boss is off this week, what am I going to do? Well, I'm going to approve and complete the merge of my branch back into my main branch. I'm going to just self-approve. Let's just go ahead and say, shh, nobody saw that. So what we're going to do is jump back across into the pipelines, and you'll notice now that we've merged that back in, it's now triggering an additional continuous integration build, which of course will include anything else that was approved and merged in the time that it took us to approve that pull request. So now that's just doing one further CI build. We've already built it twice at this point. We've validated it. We've built it. Enough with the building already. What are we, builders or coders? No, we've built it. We're generating an artifact from that, and then we can go ahead and promote that to later stages. And that's what's going to lead us on then to the final thing that I want to talk about, of course. So back to the slides we go. So we've pulled it back, dedicated dev and test environments. Excellent. We've used the clone as the baseline. Amazing, fantastic. We've been able to check out branches and seamlessly switch between them, which for databases is almost unheard of. We've then been able to raise a pull request and deploy immediately to a live cloned database as part of the branch policy. I get giddy just talking about this. I don't know how you all aren't as excited as I am. I'm going to be looking at the comments. I've been too much in a flow to get to the comments, but I will. Effectively, that's then spun it up for us. It's continuously integrated it, it's built it, it's deployed it. But then what happens as a result of that build? Well, that is when we can then actually look to create an additional deployment. So that's now created a new artifact, and I can now create a release here using that latest package, release 36, which has now been queued. And if we take a look at that, it's now starting to deploy those changes to integration. Excellent. We're happy with that. That's fantastic. But what can you do at these particular stages? Well, where is clone going to fit in here? Well, the final place I want to talk about is, of course, release candidates. Now, what I mean by release candidates is a lot of people talk to me about, well, we often deploy to integration, but the problem with integration is that when we deploy something that we don't approve, or that's not good quality, or that fails, or causes everything to blow up, how do we roll that back? Well, I'm going to answer that in two ways. The first way that I'm going to answer it is by saying, number one, you should have rigorous testing, workflow management. You should have checks and pull requests and validation and builds and builds and builds galore, so that nothing you deploy to integration at this point, because you're building and deploying your main branch, by the time you deploy to integration, that should all be tickety boo, as we should say. That should all be absolutely A-OK. But naturally, the real world exists. So if we wanted to deploy to an environment that we didn't then have to roll back dynamically, well, there's nothing stopping us from using a clone for one of these environments. So I'm just going to promote to testing. But what we can do is spin up a clone, as you saw, using a very similar workflow. If I come over to the release pipeline and we actually have a look at this release pipeline, let's just edit it. You'll notice down here for acceptance, we can create a new image from, say, the production database or from a backup. That's absolutely up to you. I can then create a clone of that database. So I'm literally getting the most up-to-date copy of the database, cloning it, and then deploying to it. That's all there is to it. That's all she wrote, folks. But effectively, what that allows us to do is just check that, hey, is everything working? Is everything okay? And that's exactly what will happen here with our acceptance database. We can ensure what goes out is representative of our version control. We can validate our continuous delivery to a clone specifically. This is going to create an image. You can actually see our pull request database being created by clone there. And yeah, it's going to create this image of the voice of the DBA production. It's going to create it as 37, finalize it, then it's going to spin us up a clone. So it's deleted the old acceptance database, spinning up a new one, and then hopefully within Azure DevOps, we should notice if we go to the logs, that it's now going to deploy that same artifact that's been deployed against integration and testing. Again, this whole stage could come way earlier in the process as well. You could come up with, say, you could spin up integration and deploy to that, and then roll it back, for instance. We've got another question. So is there an upper limit to the database size for SQL Clone? Yes, there is. Absolutely. Naturally, there's technology. Technology has its limits. 64 terabytes. 64 terabytes per database. Yeah, I don't know too many people with databases bigger than 64 terabytes. If you do have a database bigger than 64 terabytes, I got nothing, but that is pretty big. It's very unusual, certainly, for us to talk to people who have databases bigger than 64 terabytes anyway. So we've now run that, and we've deployed to our acceptance database. We've checked that that's going to work. That is purely an automated check for us that this is working. We then also have a manual intervention step to now deploy to production. And I can say, yep, worked on the clone, another smiley face, and hit resume, and that will deploy to production. And there we go. That is how we can use SQL Clone in basically every part of the DevOps pipeline. Source control, CI, CD, it really is your pick. Now I'm going to stop sharing and come back to me. Hello. And I'm just going to move us on and just say, if you want to know more about this before we take any additional questions, if you want to know more about this process, for instance, I've picked out 3 of my absolute favorite resources available with Redgate, and you should have access to my slides somewhere in the magical On24 widget. Now, the 3 things that I've picked are the webinar that Kendra's doing in September. She's going to be talking about all of this as well, and naturally she will be more concise, valuable, informative, helpful, wonderful than me, but I'm not going to devalue myself. I thought this was pretty great. The documentation as well for using a SQL clone image as a baseline. So that's how you can use that to speed up your source controlling of your database. That really can't be overestimated. It's fantastic. And then also the product article that was written about seamless database branch switching as well. So if you want to give your developers that kind of true agility in development to be over here and then over here and then over here again, well, you can do that as well. There's the article and the link to everything that you like.